Hey everybody, it's Mr. Carr again. Today we're going to be talking about 6.2, inverse functions and relations. So let's talk about what is an inverse relation first. Let's say I give you these order pairs, 1, 3, 6, 3, 6, 0, 1, 0. To find the inverse relation, we are just simply going to be switching the x values and the y values, which means every xy coordinate is now going to be yx. So what that means in here is for this rectangle, my inverse rectangle, will be made up of this set of points. Whoops. Yeah, I could draw that a little better. Okay, it's going to be the set of, in the first case, we'll have 3, 1. The second one is going to be 3, 6, 0, 6, and 0, 1. Okay, so that's what happens to that. So we just switch those x and y coordinates. That's it. Now, when we look at, say, it's something like this, and we talk about an inverse, okay, find the inverse of f of x equals negative 1 half x plus 1. I'm still going to use the idea of switching x and y. Okay, so just like we did on the previous problem, we just switched the x and y values. Right now, I'm going to do the same thing. Remember, f of x, I can treat it like it's a y. So if I have y equals negative 1 half x plus 1, I'm just going to switch x and y with each other. So x equals negative 1 half y plus 1. To get the inverse function, we now have to solve this for y. To do that, I need to get, if I look at this, this is being multiplied and then added. So I need to subtract first. X and negative 1 do not go together, so I'm going to leave it as x minus 1 equals negative 1 half y. And then I need to undo multiplication by the fraction. So I can do that by multiplying by its reciprocal, negative 2 over 1. And that happens to both sides. Now, I could just leave it like this, where I have negative 2 times x minus 1, but it might help to just kind of simplify it a little bit by distributing out. So if I do that, I'm going to get up here, I'm going to have negative 2x plus 2. But instead of writing it as y, we're going to do the inverse of f of x, which looks like this. This means inverse. So f negative 1 of x. Okay. Now, when we look at the graph, here's the graph on the next page. So just like we've done before, linear functions, graph here, slope and y-intercept. Here's the graph right here. So negative 1 half x plus 1. The inverse function is negative 2x plus 2. What's happening here with inverse functions? And this is a big key here. Inverse functions reflect over the line y equals x. That's what this line is right here, y equals x. And so what we mean by reflection is every point that I have on here, for example, this one, it's positive 2, negative 2. That maps over here to negative 2, positive 2. Okay? Those are reflections of each other. So if I pick this point here, it reflects here. They're reflections. They're jumping over that line, making this mirror image. So that's what we create here with inverse functions. They are reflecting over the line y equals x. And that's where we keep getting our swapping of x and y values. Okay, so this is another example. Again, do it on your own, but start off by saying y equals 1/3 x plus 6. Swap the two values so that x equals 1/3 y plus 6, and then solve for y. Okay, so we're going to move on from the graph from that one, but you look at that one there. It's another y equals x right here. This is the graph of the inverse and everything. If I drew a little bit better, it would pass through that point. But they are flipping over each other there. Okay, but let's talk about this now. Let's tie back to what we did yesterday. How do you determine if two functions are inverses? Well, what that means is you must show that the compositions of the functions are the identity function, which means the identity function is just x. So if we can do f of g of x here, g of f of x here, and they both go to the x identity function, that means we have inverses for each other. So let's take a look how that looks. Okay, so I need to confirm both f of g of x and g of f of x. Okay, we're going to see how these both look out. So remember, f of g of x, we're going to do f of g of x like this. So my f function is going to be the outer function. So I'll do 3/4 times the parentheses here and then minus 6. This g of x function goes inside that, so it's 4/3 times x plus 8. If I go to simplify this, I got 3/4 is going to be distributed. So that means f of g of x here is equal to, this will 3/4 times 4/3 is going to give me 1x. 3/4 times 8 is going to give me a positive 6. Combine my 6 and my negative 6 together, so that f of g of x just comes out to x. Okay, g of x, g of f of x, we're going to do this similar thing. We're going to do right here, g of f of x. Looks like this will be 4/3 multiplied by parentheses plus 8. So now this whole f function goes inside of that. So it'll be 3/4 x minus 6. Distribute the 4/3 here so that g of f of x is equal to, that's 4/3 times 3/4, which is again 1x. 4/3 times a negative 6 is actually going to be, give me a negative 8 when I multiply that through. Combine my negative 8 and positive 8 so that g of f of x is just equal to x. So what we just confirmed by both sides is that because these are the same, they go to the x by itself. Yes, f of x and g of x are inverses of each other. Okay, and that's it. We just have to plug one inside. Like we have to do both, or we're plugging inside to confirm which ones are inverses for each other. Okay, this is just another example. So just remember, this function will go inside that one, but then the second time is that one's going to go inside that one for x. Okay, and that is it for today. Okay, so we're just talking about the beginnings of our inverse functions and making sure we understand that. All right, so that's it for 6-2. Take care, everybody.